Alright, good day and welcome. This lesson, we're looking at your cycle exam questions with the 5 to 10 marks that we can ask on and number systems. Alright, now subtopics. We have number systems. So number one, we can ask if you can classify numbers according to the real number system. We can also test whether you can determine whether expression is real, non-real or undefined. Converting recurring decimals to common fractions, that's a very common question we like to ask. Rounding off, approximation, estimation, or determining between which two integers an irrational number lies. So those are the basic topics that we test in a cycle exam. I'm Mr. Simons and I hope I get you to understand and cooking this topic, right? So let's start. So number one, we are looking at, can you classify numbers according to real number system, right? Identify the following numbers as real, rational, integer, natural, irrational, or no numbers. You may use more than one term for each number. So look here, the first number given, 0 divided by 7, which becomes 0. So we should know that 0 is a natural number. It can also be considered a whole number because whole numbers start by 0. It's an integer, it's a rational, and it's real. Right, second number they gave is negative 8. So negative 8, because it's negative, it's an integer, it's a negative natural number, integer. It's rational, always, and it's real. 0.49 can be written as a fraction as 49 over 100. So therefore that's considered rational and real. Negative 0.67 equal minus 67 over 100. So therefore that's also rational and real. Square root of a negative value, very important, is considered to be non-real. So when you say non-real, we mean it's not part of the real number system, right? Not unreal, but non-real, right? There is a way to solve it, but you don't do it in school maths. 0.8 reoccurring, same as 8 over 9. It's considered rational and real. 9.32 can be written as 9 and 32 over 99, therefore rational and real. Square root 15, it's 15 not a perfect square, so any square root of a non-perfect square would be irrational and real. Same here, square root 89, irrational and real. So hope you follow. So that's just classifying that. Don't expect you to have any problems if you know your numbers. Alright? Now, second thing we can test in exam, and sometimes it doesn't appear in all the textbooks, but determining for which values the expression is real, non-real, or undefined. So given to us, the question would always read, if L equals square root x plus 6 divided by x minus 5, x plus 1, for which values of x is L real? So if you remember from classification, numbers considered real, the square root is positive, right? So for the square root to be positive, I'm going to say x plus 6, the value under the square root, greater or equal to 0. Take plus 6 over, it becomes minus 6. So x is greater or equal to negative 6, right? Take note, there's also a restriction. X there can't be 5, because 5 minus 5 would give me 0. And anything divided by 0 is undefined, right? X cannot equal minus 1, because minus 1 plus 1 would also give me 0. Anything divided by 0 would then be undefined. So there, whenever we ask real, we want to ensure that the square root is positive, not negative, right? Then they can say for which value is x, L equal to 0. So this can only be 0 if the top of the fraction is 0. So I'm going to say square root x plus 6 equals 0. If I square both sides, the square root would fall away. 0 squared stays 0. So therefore I have x plus 6 equals 0. And if I take 6 over, x equal to negative 6. So then negative 6 plus 6 would give me 0. Square root of 0 is 0. And 0 divided by that would then give me 0. Alright, number 3, for which values of x is L undefined. So for it to be undefined, the bottom must be 0. So there, if I make x minus 5, x plus 1, 0. So therefore x equal 5 or x equal minus 1. Because 5 minus 5 is 0. Anything divided by 0, undefined. Minus 1 plus 1 is 0. Anything divided by 0, undefined. Right? And they say L non-real. So for it to be non-real, the square root must always be less than 0. Meaning there's a negative under the square root. So x plus 6 less than 0. If I take 6 over, x less than negative 6. Right, so hope you follow, you understand. We're together so far, right? Still following me, right? Let's look at another problem like this. Right, determine for which values an expression is real, non-real or undefined if r equal x plus 4 square root x plus 12. So from the previous one and this one, you can see I've moved the square root to the bottom. X plus 12 for which values of x is L real, L equal to 0, L undefined, L non-real. So what you can do, you can pause, look at what I've done, find a similar problem in your exam book or past exam paper, and answer. It's just a process. So if you learn to follow the process, there should be nothing difficult. So for it to be real, right, x plus 4 on the top must be greater or equal to 0. Right, so if I take 4 over, x greater or equal to negative 4. Take note again, x cannot be equal to negative 12, because if I say negative 12 there plus 12, it would give me 0, and anything divided by 0 is undefined. Right? Right, L equal to 0. So for it to be 0, the top must be 0. X plus 4 equals 0. Take 4 over, x equal negative 4. And for it to be undefined, the bottom must be 0. So x plus 12 equal to 0. If I take 12 over, x becomes negative 12. The only time it becomes non-real is whenever we make the square root negative. So meaning less than 0. So x plus 12 less than 0. If I take 12 over, x less than negative 12. So this is how we would test for you to determine if expression is real, non-real, or undefined. Right? We could have also said there x plus 12 greater than 0 and solve that. So x would then be greater than negative 12. Right? For real. Okay, let's look at the next subtopic. Right now, yeah, very common question. We enjoy asking it in exam, converting recurring decimal fractions to common fractions, right? So, write 0,4 recurring as common fraction. So, we're given 0,4. We expect you to know that 0,4 is 0,4444 going on indefinitely, right? Are we together? Right, so you start off and you say let x equal 0,44. Right? Because I have 1 4 recurring after the comma, I need to move the comma one space to get a natural number in front of the comma. Right? So there we either going to multiply all this by 10, 100, 1,000, etc. All in multiples of 10. To ensure we have at least one natural number in front of the comma and a recurring digit after the comma. So there if I multiply by 10x, the comma moves one space and I end up with 4,44 recurring. Right, so there's my equation 1. Here's my equation 2. Right, so 10x equal 4,4, negative x equal, right, so 10x equal 4,44 recurring, negative x equal negative 0,44. Right, that's my two equations. I subtract equation 1 from 2. So 10x minus x give me 9x. And now you see by ensuring I have only recurring digits after the comma, the 4,444 recurring, 4,44 recurring would subtract. Remember, I want to go to common fractions, so I must have no decimals left. So I have to get rid of these decimals. So 4 minus 0 give me 4. We always divide by the coefficient of x, which here you should see is 9x. Right, so 9x equal 4. So 4 divided by 9, so x equal 4 over 9. Right? Now let's look at a more complex recurring problem. Alright, so in this problem now, we're converting 8,46 to a common fraction. So here we've already given you a value in front of the comma. Alright, so 8,46 is the same as saying 8,464646, continuing indefinitely. Right, so if x equal 8,46 reoccurring, I need to move that comma 2 spaces to get both recurring values in front of the comma. So I only have 46 reoccurring. So therefore, to move 2 spaces, I need 2 zeros. Therefore, I'm multiplying by 100. I hope you follow. So I multiply by 100, my comma moves 2 spaces, and now I have 846,46 reoccurring. Right, so that's my equation 2. So if 100x equal 864 or 846,46, right, minus x equal that. If we subtract 100 minus x gives me 99x. That should read 846. Somehow I typed 864. Forgive me. So 846 minus 8 gives me 838. From there, always divide by the coefficient. So 838 divided by 99, and if we simplify, 99 goes in 838 8 times, leaving a remainder of 46 over 99. So hope you follow. Here the key was I had to multiply by 100 because I had to move the comma 2 spaces, right? So I hope you understand. If not, pause, redo it, check. Feel free to ask any questions if you'll have to redo anything. But it's just to prepare you for what you would possibly ask in an exam. Now we can make this more complex. So we look here, convert 1,0832 to a common fraction. So given 1,0832 reoccurring. Right, so the 0 there is not reoccurring, right? But the 832 is reoccurring. So first I have to get the 0 in front of the comma, right? So I'm going to multiply by 10. If I multiply x by 10, the comma moves 1 space. So 10x then equals 10,832 reoccurring, right? Then I need to move the comma past all 3 the recurring digits. So therefore, to move from 1 here, it's 1, 2, 3, 4. So there I'm multiplying by 1,000. I actually should read 10,000. I made a typing error. Right, so 1,000, or that should read 10,000x, would then give me 10832,832. Right, so 1,000x minus 10x give me 9,990x. And now the recurring part 832 cancels. 10,832 minus 10 would then give me 10,822. Right, subtract or divide the 2, not subtract. 10,822 divided by 99990 or 990. There, that goes in 1, remainder 832 over 9,990. So that is how I would convert recurring decimals. So very important, any number after the comma that's not recurring, I first have to get in the front. In this case, I had to multiply only by 10 because I had to move 1 space. Then to get all 4, you see I have to move 4 spaces to get all 3 recurring, I had to multiply by 10,000. Ignore the error there, must be an extra 0. Right, so by 10,000, because that's 4 zeros. And then from there, you just subtract. Make sure there's no recurring digits left after that, because a common fraction can't have decimal fractions in it, right? Hope it makes sense. Right, let's go to the next subtopic. Right, rounding off, approximation, and estimation. Now, rounding off is very important, especially for mathematics, physics, wherever subject you get calculations. So sometimes you can have calculations in bio or life sciences, as you call it, geography, etc. Most of the time we'll ask you to round off. Alright, so 1, round off 582.47 to 2 decimal places. What do I mean with 2 decimal places? I want this value to read 5.8, 2 or 3 based on 2 values after the comma. Right, so here's 4 digits after the comma. The third digit there, as you can see in the red, is 4. That value in itself is less than 5. So if that's less than 5, it doesn't change the first 2 decimals. So therefore, 5.8247 simply stays 5.82. Right? Can say round off 4246 to the nearest 100. So we expect you to know that 246 there represents my hundreds, 246, because 2 is in the place of hundreds. Value after 2 is 4, which is less than 5. Therefore, if I round to the nearest 100, I can't go to 300, but I go down to 200. So 4246 would then give me 4,200. Can also say round off 0.0746 to the nearest 1000th. The fourth in the place of 1000, due to it being the third place after the comma, right? So there, 1, 2, 3, third value to give me 1000, meaning that would be 74 over 1000 by 0.074. The number that follows 4 is 6, which is bigger than 5, so 746 to the nearest 1000 would then become 0.75. Therefore, the 6 changes the 4 to 5. Right, let's look at another problem. Round of 18.96 or 9367 to 2 decimal places. So there are 4 digits after the comma, right, which is 9367. Third digit there is 6. So any value there, the third digit that is 5 or bigger than 5, would then ensure that we can round up the value before that. So comma 93 would then now become comma 94. So we round the digit up. So 6 changes 3 to 4. Round off 7356 to the nearest 100. So 356. 3 represents my hundreds, right? 5, which is greater than or equal to 5, would then ensure that 3 would become 4. So 17356, if I round it to the nearest 100, would then become 17,400. So that's just some basic rounding off. Now let's look at some approximation and estimation. Right. Now this year we're doing more in a sense that sometimes your answers are impossible. You'll see in financial maths, learners invest 1,000 rand. 2 years later, they've made 3 or 4 million rand, which is not possible. Then we'd all be well off and set. Right? So, rounding off, assume you know these 2 small signs means approximately almost equal to. So here, estimate the value of the following. So 1, they said 29.76 times 3.24. Right, if we use our knowledge of rounding up and rounding down, 9.76 is approximately 30. 3.24 is approximately 3. So 30 times 3 would give me 90. Oh, the way I'm making errors here, man. So 30 times 3 would give me approximately 90. I don't know how I get to 60. I'm making now things, so excuse my error there. We take number 2, 89.679 divided by 9.0325. 89.679 is approximately 90. 9.0325 is approximately 9. 90 divided by 9 gives me approximately 10. Right? Take a longer sum there, 8.57 times 3.92 plus 13.93 divided by 8.23 plus 1.7. Right, so 8.57 is approximately 9. 3.92 is approximately 4. 13.93 is approximately 14. 8.23 is approximately 8. And 1.7 is approximately 2. So 9 times 4 would give me 36. 36 plus 14 would give me 50. 8 plus 2 is 10. So 50 divided by 10 then gives me 5. So what we are saying is the sum here would approximately give me an answer close to 5. The sum should give me an answer approximately close to 10. So just below 10, 9, something something, or 11, something something. There, that should give me an answer approximately close to 90. Right? Let's see what here. So there, that would be 90. Right, let's look at the next slide. So determining between which two integers a irrational number lies. So this we normally ask for 2 to 3 marks in exam. To answer this, number one, we need to understand what our perfect square numbers are. So we have 1, 4, 9, 16. So this all comes from 4 times 4, 5 times 5, etc. Right, you should know all the way up to 169 according to what the department says. So now ask between which two integers does a irrational number lie? Remember, this number is irrational because it's not a perfect square, right? So square root 57, the number 57 would fall between the number 49 and 64. Right, 57 would slot in between there. So square root 57 equals square root 49 and square root 64. And square root 49 is 7. Square root 64 is 8. So that answer falls between 7 and 8. Right? We can also do it a different way. We say square root 57 is greater than square root 49 or less than square root 64. So therefore square root 57 is greater than the value 7 or less than the value 8. This and this mathematically means the same thing. Right? So square root 57 will give me an answer of 7, something something. Look at the second example, square root 46. So 46 falls between 36 and 49. There, do you see that? The value. So therefore, square root 46 would fall between the perfect square, square root 36, and square root 49. Square root 36, which equals 6. Square root 49, which equals 7. So therefore, square root 46 would give me an answer between 6 and 7. Or I can say square root 46 is greater than square root 36 and less than square root 49. So square root 46 is greater than 6 but less than 7. Right, let's look at some more. Determining between which two integers a irrational number lies. So negative square root 15 would then fall between negative square root 9 and negative square root 16. 9 there, 3, so negative 3 and negative 4. If I said negative square root 132, 132 falls between 121 and 144. So negative square root 121, which gives me negative 11, and negative square root 144, negative 12. Right, so I do it differently. Negative square root 15 would be greater than negative square root 9. That would be less than negative square root 16, square root 9, 3, square root 16, 4. So negative square root 15 is greater than negative 3, negative square root 15 less than 4. The simplification further, if we said positive, that we will do under inequalities. Right, but for now, that answer is between minus 3 and minus 4. Square root 132 negative, greater than negative square root 122 and less than negative square root 144. Therefore, it's greater than negative 11 or less than negative 12. So this, in short, is a summary of what you should have learned in number systems and what you would generally test under number systems. I hope it's helpful. Right? I hope and wish you nothing but the best. Continue practicing. Right? There's only one way to master maths, and it's to do the same sums over and over. So each example I've done here, go find similar problems, practice it over and over till you know how to do it. Right? But on average, 2 to 3 of these sums would be tested for 5 to 10 marks under the topic number systems in your first cycle exam. Mr. Simons signing out. All the best. Bye.